Assalamu alaikum. Welcome to our EEE304 project demonstration video. In this video, we'll analyze the logic behind a conventional elevator system and demonstrate our developed logic to operate an elevator efficiently. A conventional elevator system has two inputs on each floor, up or down. If the elevator and a passenger are on different floors, the elevator has to make a journey to that floor and answer the landing call. The elevator calling logic system can be summarized like this. The elevator will always answer the farthest call. If multiple calls are made, the elevator will respond to the call that is farthest from the current position. A landing call will be answered only when the elevator's direction of travel matches the intended direction of the passenger waiting at that floor. Once the farthest floor has been decided by the logic system, and the corresponding direction has been set, the elevator will not change its direction until it reaches that farthest floor.
Now I'm going to talk about the Verilog implementation of our project. In order to implement the project in Verilog, first we have written a module called lift. The lift takes as its input the clock, 5-bit value pressed, which defines which floor has the elevator been called from. Then another 5-bit input, UD, going up or going down. Then we have a value called current, which gives us the current position of the lift. Trajectory has value 1 or 0. If the lift goes up, then the value is 1, and for downward motion the value is 0. Stop defines if the lift is in motion or it is stationary at some floor. And finally we have our output go, which gives us the destination floor that the elevator will go next. So first we check if any button is pressed to call the elevator or not. If the press is 0, that is none of the floor has been called from, then we go to the first floor, that is the bottommost floor. Else we enter a loop that iterates over the 5 bits of press to check which floor the elevator has been called from. If a floor has been called from, first we check if the floor that the elevator has been called from is at a upper or higher or lower position from our current position. So the first case, where if the floor is higher than our current position, then we set our next destination to that floor. If the direction that the floor the elevator has been called from is the same as the trajectory of the lift at current time, then we must stop on that floor. If this is the case, if the direction of the called floor and the direction of movement of the lift at current time is the same, then we must stop at that destination, and so we set our go variable to that floor and set a flag. If the flag is set, then here in line 30 we can see that it ignores all other next floors. If any other higher floor is even called from, then we'll ignore that and we will go to the first floor that we found has the same direction as the direction of motion of our elevator. This is the condition when the floor that the lift has been called from is at higher position than our current position. Entering the else, that is if the floor that our elevator has been called from is at lower position than our current position, then we similarly use a flag to set if the direction of the call from the floor is the same as the trajectory of the elevator. If it is, then we set that our destination and ignore all other calls. Otherwise, we set the destination to be the bottommost floor. In the previous case, we set the destination the topmost floor if we didn't have any other floors below it that had the same direction of call. Now we're going to test some cases to test if our model is working or not. We have set the current floor to the first floor, that is lift is at the bottommost floor. We have calls from 2 floors, as we can see in the pressed variable. We have call from the 5th floor and the 2nd floor. The 5th floor wants to go down and the 2nd floor call also wants to go down. So according to our logic, the lift should first land at 5th floor. After answering that call, then our elevator should go to the 2nd floor. We see that it does in fact first go to the 5th floor. The first line shows us the initial position of the lift. The lift is at a first floor. It has the same destination since it's at stop. Its stop is 1, so the lift is stationary there. We have no trajectory since the lift is stopped. None of the button is pressed. Next, buttons are pressed. The 5th and 2nd floor buttons are called. Our destination is set to 5, which is desired. and which follows our logic. Trajectory 1, that is our lift is going up now. Stop 0, that is our lift is in motion and it's going up. And as it goes to the 5th floor, we see in this line the elevator has reached the 5th floor, then it stops at the 5th floor. Next, as the lift stops, we have turned off the call from the 5th floor since the call has been answered. As we can see here, the 5th bit is 0. Also, the up and down bit has been changed to X since the call has been answered. Now our next destination, as we see here, is set to 2nd floor. Then the lift gradually goes down. The trajectory is 0, as the elevator is going down. And as we go to the 2nd floor, we see again that the lift has stopped here. The stop bit is set high, the press button is set low, so we have no other calls to answer anymore. So since we have nothing to answer, no other calls to answer, we go to the bottommost floor, that is the 1st floor. And as we reach the 1st floor, the lift comes to a stop. Stop bit is set to high. So we see that our module works.
Assalamu alaikum. My name is Mohammed Jainalom and I am going to be presenting Proteus design part of our project. Now we can see the important parts. We can say the inputs and the outputs. There are 10 buttons here, which indicate the up button and the down button of each floor. So this is the 5th floor, this is the 4th, 3rd, 2nd, and the 1st floor. This is the current position indicator of the elevator. So if I simulate, there are no buttons pressed. The elevator is in the 1st floor, and by default, the elevator needs to go down. Let us think that someone at the 3rd floor wants to go up, while the elevator is on the 1st floor. The circuit generates the decision that the elevator needs to go up, and we can see here the 3rd floor gets called. This indicates the furthest point from the elevator. So if there is another call intermediate to the 3rd floor, suppose the 2nd floor, maybe the passenger wants to go up as well, the lift from the 1st floor will go to the 2nd floor, pick up the 2nd person, and go to the 3rd floor and pick up the 3rd person. In that case, the lift or the elevator has to stop on the 2nd and 3rd floor. As we can see here, it stops at the 2nd and 3rd floor. The furthest point is still the 3rd floor. What if someone from the 4th floor wants to go down and someone from the 2nd floor also wants to go down when the elevator is on the 1st floor? Being that the 4th floor is the furthest one from the elevator will go to the 2nd floor as its trajectory is now upwards. It will not stop on the 2nd floor because the 2nd floor's desired trajectory, or the passenger where they want to go, is not in the same direction as the elevator's current trajectory. So it will ignore the 2nd floor. As we can see, the 2nd floor is ignored. It will go to the 3rd floor, it will be ignored, and the 4th floor where it will stop. What if the 2nd floor passengers want to go up, aligning with the current trajectory of the elevator? In that case, the elevator will stop at the 2nd floor and also at the furthest point. The 5th floor passenger wants to go bottom, and everyone under the 2nd floor, the 3rd floor, and the 4th floor wants to go up, aligning with the trajectory of the elevator. It will all light up, where the 1st floor will not, because the elevator is already there. Now, let us reverse the conditions where the elevator is on the 5th floor, where no button is pressed. By default, it shows down. However, if the furthest point from 5 is, suppose, 2, the elevator will go from 5 to 2 and it will stop on 2. If in between the intermediate steps of 4 and 3 wants to go downwards, it will stop at 4 and 3 because the lift is already going downwards. But if the elevator going downwards, 4 and 3 wants to go upwards, it will be ignored, as can be seen here. What if the elevator is in between 2 calls? Suppose the elevator is on 3 and there is someone on the 4th floor who wants to go downwards, and there's someone on the 1st floor who wants to go upwards. The furthest point from this elevator position is 1, not 4. So it will ignore the 4th position and go to 1. So the 4th position is ignored. If, however, there is some intermediate passenger in 2 who wants to go downwards, aligning with the direction, it will stop there. But if the direction is reversed or the opposite, it will not stop there. As for the circuitry, we use comparators for comparing and producing the trajectory. We used priority encoders with 5 to 1 priority and 1 to 5 priority to produce the furthest or the highest and lowest points as we needed to calculate the furthest away points. And here are the difference finder using two subtractors, here and here. If we subtract from the first value to the second value, if the second value is smaller than the first one, the subtraction takes place with no complication. But if the subtraction produces negative value, as for the closest point it generates one, there's a borrow value generated, and we use 2's complement to generate the absolute of the negative value that we get. So if there's any carry in Q4, that is ignored. This is how we produce the difference between the current position of the elevator from the from the highest point of call and the lowest point of call, and find which one is higher. And using a comparator and some gates, we pass the furthest away point to the furthest away point finder circuit. This is the actual schematic or the blueprint we use to find the decision factor. The encoder, the comparator, and the gates are all simplified to be seen here. And also, the furthest away point is created through this. That was all for our project. Thank you for being with us. If you have any questions, feel free to ask. We will try our best to answer them. Thank you very much.